Welcome everyone to my talk on securely unifying deployments in an organization for increased governance. I'm Hariharan and today we'll explore how secure deployment practices can enhance governance within organizations. Let's get started. A quick introduction about myself. I'm currently a software engineer at AMD and have previously worked at Athena Health, Bain Capital and Bose Corporation. My interests span DevSecOps, distributed systems, applied AI and embedded systems. Feel free to connect with me on LinkedIn or check out my GitHub repository for more insights into my work. So here's the agenda for today. We'll start with the organizational journey and then discuss the importance of security. Next, we'll deep dive into the unified deployment model we implemented based on case studies, governance practices, and wrap up with the future directions and key takeaways. So let's begin. Organizational journey. The deployment landscape before unifying deployments or before the unification was fragmented and passed several challenges, including inconsistent processes and vulnerabilities. This drove us to embrace a DevSecOps approach to unify deployments and address these challenges proactively and comprehensively. So if you look at this slide, with multiple teams working on deployments, each team had their own strategy to deploy artifacts or containers. Some of them decided to deploy to EKS, some of them deployed ECS, and some teams had their own homegrown deployment strategies. So as we had some metrics and some monitoring tools to track the number of deployments and the type of deployments, we realized that we did not have a unified way to govern all these deployments or set rules or strategies or address vulnerabilities and so on, which drove us to the DevSecOps journey. So our DevSecOps journey focused on shifting security to the left by integrating it into CI/CD pipelines. Collaboration between developers, security, and automation teams was essential to achieve security across the software supply chain, commonly referred to as SSC, especially with increasing reliance on open source software. So there was a rapid increase in the usage of open source software and the number of packages and versions in open source software released per year was also rapidly increasing. So let's try to really understand why is security supremely important? What is the need for security in deployment pipelines, and how is all this helping in governance, right? So first, security is crucial because modern applications heavily depend on open source software and third-party components at every stage of the SDLC. So if you take a look at the next slide, at every stage of the SDLC, third-party components play a pivotal role. This dependency exposes to vulnerabilities, and addressing these proactively is a non-negotiable. So there's a growing attack surface, right? So when you look at the attack vector in the deployment pipelines, there can be supply chain attacks, they can be secret management attacks, they can be misconfigurations, such as giving excessive permissions or using unverified images. For example, if you take a real-world incident like Log4j, that had tremendous impact, right? So the idea is to follow some key security practices by ensuring that we care about security at each stage of the SDLC. For example, we can have immutable infrastructure and container scanning. We can have RBAC, role-based access rules set. We can have digital signing of artifacts. We can have automated compliance checks, right? So, and shifting security to the left, we can involve SAST and DAS scans at very early stages of the pipeline. And finally, we should also inculcate a DevSecOps culture across the entire organization. So the software development lifecycle begins when anything enters the ecosystem and ends in production. Threats like CVEs, malicious packages, and supply chain attacks underline the need for robust detection and remediation strategies. But when you zoom out and look at it at a very high level, right? All these threats that come into the SDLC, they can be classified as source threats or dependency threats or build threats. Source threats are some examples of source threats are submitting an unauthorized change, compromise or the entire source repository is compromised, or you forked a repo and you're building from a modified source. Dependency threats are essentially like using compromised dependency. Our build threats can be compromised build processes, compromised packages, compromised or someone had inadvertently uploaded a modified package and so on. But the current approach towards security as a whole is to detect it and remediate it, but the idea that should trickle down is to prevent it. right? So that it doesn't even happen in the first place. So let's dive a bit deeper in understanding securities, vulnerabilities, CVEs, and then how we could potentially address them, right? So the rate of published CVEs is rapidly increasing every day, creating a constant pressure on dev and security teams. So this data is like publicly available, and the irony is that many of the critical CVEs that are reported, not all of them are fully exploitable, right? So only fully exploitable CVE is really dangerous, but then majority of the CVEs are not exploitable at all. Like for example, if you look at the screenshot here, you can notice the message saying that the vulnerability has been modified since it was last analyzed. It's awaiting reanalysis, which may result in further changes, right? So given in the last few years, given the rise of ML models and generative AI, even machine learning models can be weaponized. Public repositories for models have become targets where attackers embed malicious code that executes when the model is loaded. This shows the sophistication of modern threats and the importance of how we should care about security at every stage of the software development lifecycle. So, for example, this example is like if you take a look at this model called Totally Harmless Model, completely named for the irony. It looks like a very legible model, but then when the model loads and the malicious code actually executes, right? And the malicious code is actually hidden in the binary data. So there is also generative AI tools are now introducing vulnerabilities as well, such when they hallucinate, right? So where a developer inadvertently installs malicious packages. For example, if you take a look at this flow, the attacker essentially asks ChatGPT or an equivalent Gen AI tool a question, and then when it hallucinates, it responds with an non-existent package. And the attacker decides to publish that package into the respective container registry, with malicious code in it. At a later point of time, a developer asks the same question, and then the generative AI model replies with the same malicious package name, and then the developer goes and grabs it from the container registry. So this flow of injecting malicious packages and then affecting developers, this highlights the urgent need for secure coding practices and dependency management. And also, right, so the next natural question that comes to our mind is, do generative AI tools, can they write secure code? Can they ensure that the code written or is devoid of, vulnerabilities themselves, right? But on the left, if you ask ChatGPT or any other generative AI tool to write an endpoint that runs a file, the generated code is vulnerable to path traversal. And even if you explicitly make it to write a secure endpoint, it still doesn't help because it's still vulnerable, right? So we should really be careful when trying to use the generative AI tools as well, and analyze these scenarios from the security posture. So taking a look at the various software supply chain security types, supply chain vulnerabilities include known CVEs, zero-day attacks, even human errors leading to malicious injections. Understanding and mitigating these risks is vital for building security systems. We'll talk more about this in the upcoming slides. But how did all this happen, right? So by this point of time, it must have been pretty evident that the code a particular developer writes contains probably code, artifact, and some packaging materials and some security aspects as well. But the other stuff other dependencies that were pulled in during the build definitely can have a lot of vulnerabilities. Moving on to the next slide. So what can we do better, right? So to combat these issues, I sort of put in a 7-step process here where we educate ourselves, we don't rely solely on public reports, we manage our dependencies and permissions, continuously maintain our code base, regularly scan our libraries and packages, and optimize our CI and CD deployment, continuous integration, continuous deployment pipelines. To regular scanning and optimize, but all these 7 steps are equally critical, and these help and these 7 steps are, I would say, the first step in the right direction because they help in combating common vulnerabilities, right? So if you take a look at common vulnerabilities, they are cross-site scripting, SQL injection, CSRF. So organizations must prioritize awareness and adopt guidelines such as provided by organizations by OWASP to mitigate those risks. But this also sets the path or rewrites how developers operate on a day-to-day basis. So this diagram underlines the importance of declaring dependencies as we write code or as we build code or as we run code, right? So if you see the first and third column are just highlighting the fact that we have to declare dependencies before writing code and before building code. and then only code is run and it's actually like deployed. So diving a bit deeper into software supply chain threat types, CVEs are generally reported on vulnerabilities. They can be intentional vulnerabilities or unintentional vulnerabilities. Unintentional vulnerabilities are security bugs. Intentional vulnerabilities are a backdoor into the system. But on the other hand, malicious payload code or malicious components are not a CVE, right? So this distinction is critical, as we'll talk more about it in the upcoming slides. So how can we shift left to the developer? So this screenshot, so in one of the previous organizations I had worked, we extensively used Artifactory and its ecosystem. So Artifactory comes with a tool called X-Ray. So X-Ray had its own plugin that can be installed in IDEs. So I'd actually installed the X-Ray plugin in my PyCharm IDE or my C-Line IDE. And as I write code, the X-Ray plugin looks out for vulnerabilities in my code and then reports it in my developer console that I can actually like fix and before I actually check in my code into the code repository. Yeah, another big component in ensuring that we care about security, governance, and during unified deployments is the software bill of materials. So what is software bill of materials, right? So let's try to understand what that is. Software bill of materials is like a list of ingredients that makes up what's inside of the software. And different people look at the software bill of materials with a different lens, right? So, but before that, it's a list of ingredients that make up what the software is. It includes libraries, modules. It can be open source or proprietary, free or paid, and it can also contain data that's widely available or access restricted, right? So it'll also contain characteristics like settings, versions, environment variables, and so on. So as I mentioned, there are multiple consumers of software bill SBOMs, right? So for those who produce software, SBOMs are used to assist in the building and maintenance of their software, right? Including upstream components. For those who purchase software, right? SBOMs are used to inform pre-purchase assurance or like can help in negotiating discounts and so on. For those who operate software, it can inform them about their vulnerability management and asset management, managing license and compliance, and to quickly identify software or component dependencies and supply chain risks. The overall benefits of SBOM is it helps in identifying, mitigating known and avoiding known vulnerabilities, right? And quantifying and managing licenses. It also helps in enabling quantification of those risks inherent in a software package. In the long run, it can also contribute to lower operating costs because it improved efficiencies and reduced unplanned and unscheduled work. Overall, it provides a comprehensive information about the overall software package and environment and what setting it's actually being used at. But we'll talk about how SBOM play a critical role in the unified deployment pipeline as well, or like how they fit into the unified deployment pipeline. When we look at a detailed diagram. Yeah, so this was the diagram I was talking about. So this is one of the architectures we had implemented in one of the previous places I had worked. So what we decided that since multiple teams had different deployment strategies, like I had previously mentioned when we started talking about unified deployment models, there was a movement to ensure that all teams deploy to EKS or like Kubernetes style deployments, right? So we created this flow where a developer checks in a piece of code. And of course, while he checks in a piece of code, he'll be having an IDE that is fully furnished with X-Ray plugin that can detect vulnerabilities at a very early stage. And the code is actually checked into the application code repository. And once code is actually checked into the application code repository, we have the tool Jenkins that constantly, there's a webhook listener to the GitHub repository, to the application code repository. It can be GitHub or Bitbucket. It listens and then it starts running the CI build for that branch. Once the CI build completes, it deploys an artifact into the container registry. Here we use Artifactory. And there, depending on the environment we would like to deploy that artifact to, it runs X-ray scans based on rules that we have set for that environment. Once the scans finish, an SBOM is generated, which contains all the details that I previously mentioned, that informs the developer and also the team as to whether that particular artifact is deployable or not, or what we could do with that artifact. Assuming everything is great with that artifact, there is a deployment orchestrator as well. The deployment orchestrator you can visualize it as the choreographer of all deployments, right? So the deployment orchestrator has a webhook listener as well. And once the SBOM is generated, it decides to kickstart the act of deployment. The deployment orchestrator then decides to go and talk to a compliance advisor service. The compliance advisor service over here is an open policy agent that has a set of rules for any kind of deployment, right? So these rules are written in a different language called Rego, and any deployment across the org has to adhere to these rules. So the deployment orchestrator, who's our choreographer of deployments, goes and asks the compliance advisor, hey, can I actually go deploy this artifact to this environment, or is it following all the rules? And once it gets a response, assuming we get a response saying like you can deploy, it begins to start checking in the hem release manifest or the appropriate Kubernetes manifest to the GitOps repository. And once that manifest actually gets checked in, we typically use Argo CD or Flux CD to manage the deployments, and then the Argo CD or Flux CD constantly listens to the GitOps repository every 30 seconds or 60 seconds, and then decides to apply that manifest onto the cluster, by which resources actually get deployed into AWS, Azure, or any other environment that the team cares about. So this is a very zoomed out high level flow. But as we actually dive deep into every component of interest in this diagram, there are multiple layers of policies that map to security, governance, unification of deployment, and so on. For example, if you zoom a bit into the Artifactory, the folder structure is neatly manipulated based on the environment the artifact should be deployed to. Each folder is tightly follows RBAC policies that have been set, and accessing Artifactory itself is highly restrictive and is managed by IAM policies and credentials that have restrictive access and so on. So the point I'm trying to drive home is that this is a very zoomed out view, and then there are multiple layers to this diagram as we deep dive. Moving on to the next slide, let's talk a bit about governance and how the governance fits into this entire puzzle, or rather, if you visualize this as like Lego pieces, how all the Lego pieces fit together, right? So governance is not just a buzzword, right? So governance it's about ensuring that every deployment aligns with security standards and has clear ownership. This minimizes risks and streamlines operations. On one side, unified deployments help ensure governance by incorporating auditability, compliance, and accountability into the pipelines, as we saw in the previous diagram. The unified deployment framework allows us to detect issues early and enforce standards effectively. Governance is about minimizing risks and streamlining the operations. Governance plays a pivotal role in ensuring unified deployments align with organizational and regulatory requirements. Let's talk about some key components of governance, and also talk about some real world examples about how they are actually implemented or enforced. So when we talk about governance, we have to talk about auditability. We have to talk about compliance with standards, clear ownership and accountability, centralized logging in metrics, policy enforcements, and continuous monitoring. So when we talk about auditability is about the ability to track who performed specific actions, what changes were made, who made those changes, and when they occurred. The importance of auditability is it provides transparency in the deployment process, aids in troubleshooting issues by tracing the errors to specific changes, and it's essential for regulatory and internal audits. So, recollecting from memory, talking about a real world example, deployment logs are stored in an immutable data source. Like for example, if you take Amazon S3 with versioning and link to specific commits in GitHub, right? So these are auditable. Now let's talk about compliance and standards, right? So the reason why compliance and standards matter is that regulatory frameworks like GDPR, HIPAA mandate adherence to specific security and privacy standards. Non-compliance to these standards can actually result in hefty fines, reputational damage, and even legal repercussions. So it's very essential that we encrypt sensitive data, ensure that there are retention policies for logs and other artifacts that follow, and all artifacts align with the regulatory requirements, And there are tools available to ensure this happens. Like for example, if you take HashiCorp, Sentinel, or AWS config rules, they can automate compliance validation, right? A real world example would be Kubernetes admission controllers enforce SOC2 policies, ensuring containers are scanned and certified before actual deployment takes place. Moving on, let's talk clear ownership and accountability. This is very evident from the name itself. It assigns very clear roles to ensure unauthorized changes do not happen, and so overall accountability is ensured, right? We do that through setting RBAC role-based access control rules, defining ownerships, using IAM policies or Kubernetes namespaces, right? So, for example, one of the ways it is enforced is developers have access only to staging environments, while operation teams handle production deployments. And then we have three more, right? Policy enforcements, centralized logging, and continuous monitoring. Policy enforcements, as shown in like one of the previous diagrams, like we had a separate tool called Compliance Advisor Service, right? So policy enforcements are typically done through open policy agents. They enforce policies across Kubernetes clusters or like CI/CD pipelines and APIs. We can also have AWS config, which continuously assesses configurations against given set of compliance rules. And as previously mentioned, we can also have Kubernetes admission controllers that validate deployments during runtime. With regard to centralized logging, some teams have their own single source of truth to aggregate logs and metrics, but the commonly most used tools are Datadog, AWS CloudWatch, or typically ELK stack. Centralized logging, like for example, if you take a Kubernetes setup, logs from the Kubernetes pods and CI/CD pipelines are aggregated using the ELK stack, providing a single pane of glass for analysis or dashboarding or generating metrics and so on. But I also put the final one at the top layer, which is the continuous monitoring and feedback loops. And even if you look at the diagram, right, it's like a top-down approach. Top one is probably one of the most important ones, which is governance should not be like a one-time activity. It should be an ongoing process. So we need to have feedback loops where we regularly review governance policies and adapt them based on changing requirements and environments. We have to incorporate feedback from security teams, developers, and auditors to refine the overall process. With regard to continuous monitoring, we can use tools like Prometheus, which monitors resource utilization, while Datadog alerts on unusual deployment patterns. Moving on to the next. So I hope that painted a picture on what we mean by governance and how it really fits into the piece of unified deployment pipelines and the whole security angle. So what is our way forward, or like what's the future direction that we want to take regarding this? Is looking ahead, we can enhance DevSecOps pipelines by integrating threat modeling, container security, continuous feedback loops. These make security an intrinsic part of every stage of the SDLC processes, right? So we can plan and code, build and test, release and deploy, operate and monitor, feedback and improve. At every stage, we care about security, governance, and unifying all the deployments so that we have a single source of truth, and we can generate metrics and have an established feedback loops so that we iteratively improve our overall deployment pipelines. Overall key takeaway is security is everyone's responsibility. Automation integration are key to embedding security in the CI and CD pipelines. We have to design for failure or like consider and adopt strategies like multi-AZ or multi-region strategies. We need to have well architected reviews, and also even like put some sort of chaos engineering to the mix, and continuously improving our practices and ensure robust and reliable deployments. I did add a few references that help me. I encourage you to explore resources like the OWASP, Kubernetes logs, and also JFrog conferences for deeper insights in securing deployments and improving overall governance. Thank you so much for attending my talk. Thank you.